does.
All right.
I'll just kind of move this to the left here. Now we will check -7. Parentheses, -7 squared minus 56 log base b of -7. So on the left here, it becomes 49 minus 56, which is log base b of -7 equals log base b of -7. And at first glance, you say, well, hey, Matthew, they're exactly the same. They're just the same as before. They're the same numbers. That seems okay. Problem is, -7 is not in the domain.
Right. So,
Okay? And that's where you have to exclude this answer. You have to say, okay, and this is what they're looking for. They want us to say that you cross it out and say that it is extraneous.
okay.
And that is it for that problem there.
All right. So negative, it's not negative, sorry. 8 is the answer.
Yes. But it's very important to show everything that's written here. It's kind of what they're looking for the explanation.
Okay.
All right. So I believe the other issue was problem.
I think it was problem 6, maybe, because I
6.
just checked.
Yeah. All right. Problem 6 here, very similar. From yesterday, we learned that you can take a sum and make it a product. So it becomes log base 2 x minus 4 times x equals 5. So the things that are taking the log of, they multiply together. And this becomes log base 2 x squared minus 4x like this. Just multiplying that x into both the 4, that's 4x, x times x is x squared.
Okay.
And then I think we kind of started to do this. It's 2 to the log base 2, 2 to the 5th. You undo it. So this is x squared minus 4x. So this 2 in red here undoes the log base 2. And you look at what's inside. On the right, 2 to the 5th is 32. And then you subtract. You say, okay, x squared minus 4x minus 32 equals 0. Now the same thing, we have to factor again. So we have to find two numbers that multiply to -32, but then add to -4. And that becomes 4 and -8. Okay, so this is written as x minus 8, x plus 4 equals 0.
All right.
All right, and then we set each of these equal to 0. X plus 4 equal to 0. Add 8 to both sides. Subtract 4 from both sides. So x equals 8. X equals -4.
All right.
And now we have to do the same thing we did in the previous problem. We have to check. You always check back in the beginning. So we're going to check x equals 8. So it's log base 2, 8 minus 4, plus log base 2 of 8. Does that equal 5? Right, so log base 2 of 4 plus log base 2 of 8. Does that equal 5? We're not really sure, but when we have a sum, the sum becomes a product.
Okay.
So this becomes 32 because you multiply the two numbers together. And then from here, if you recall, you can rewrite 32 as 2 to the 5th power. We were doing that a bunch the other day.
Oh
Rewriting
yeah.
exponents. And then that 5 can come out in front. So 5 log base 2 of 2, 5. And then in this case, 5 times 1 equals 5. So it does work. So that one's good. We're happy about that one.
Yep.
All right, now for the next one here, we have to check -4.
All
And
right.
you notice it's almost as much work to check as it is to do the original problem. So right off the bat to start here, there's a problem. -4 is not in the domain.
Yeah.
All right, so that means that it's you cross it out and you write the word extraneous, and there you have it.
All right. Thank you for that.
Yeah, so I'm looking back at the notes, and for sure, this one, I'm looking at the notes now. So something just happened when you wrote it down, and who knows what, but this one was the same. The other one though, this one right here, it looks like the signs did get mixed up, and
Yeah.
who knows why. So, unfortunately, it's like we can't move on because your instructor is kind of blocking your path here to getting
Well,
the
y- yeah. But
but
I think
good.
that it's a good idea that he blocked me off because maybe he didn't want me just to keep going for the next lessons if I keep using the incorrect signs when I shouldn't be using them.
Now, is there a chance here that you can open up the review assignment in the next few minutes if you submit this stuff?
Yeah, I'm right now submitting the revisions and hopefully he'll check them. Because when I
Okay.
yesterday, I saw him like he graded everything late at night, and I was like, why is he awake so late? It was weird.
Okay. Yeah, because we've been sort of blocked to get to the review assignment here for a while. I don't know if there's a way to maybe communicate with him and say, hey, can you open this thing up, and I'll be sure to do the corrections. Um,
Yeah.
I'll maybe ask your dad if there's an option there as well, because we're kind of getting off track here in terms of like meeting getting this thing done.
Yep. Reading more of that. I'm just right now trying to upload the
Sure.
revision, and then I can just message the teacher saying, "Hey, can you check this, please?" All right, I'm just waiting for the file to be upload. There we go. Submit. Now I'll send him a message to ask him to check these.
Sounds good.
All right, I just messaged him.
Good.
And hopefully he responds.
Yeah, so why don't you be kind of on the lookout for that review assignment to open up? I'll also kind of check here in between us doing stuff. Obviously, we can transition to that immediately if it opens, but for now, I've got some problems pulled up that are like what we've been doing, kind of a continuation from yesterday, unless you have some other things you want us to work on.
No, look, we can just continue with the logarithms from yesterday.
Okay.
I'm fine with that.
So here's kind of a sample problem. I called this case 2. It's kind of like one of the last problems we just did. You have to undo the logarithm. So in this case, to undo log base 3, you use 3 to the log base 3. So on both sides, there's a 3, and that's the base. Log base 3, 5x minus 2 equals 3 to the 2. Okay, so
Okay.
on the left, this undoes the logarithm. It's gone, poof, it vanishes. So we got 5x minus 2 equals 9. How do you
Okay.
solve an equation like this from yesterday? Do you remember?
So what I would do first is move the 2 over to the 9. So I would add 2 maybe.
Okay, I agree. Add 2. So this becomes 5x equals 11.
Yes. Now what I will do is divide by 5.
Yep. And this one's just a fraction, just doesn't happen to doesn't
Yeah.
have you could write as a decimal, but and go from there. All right, so
Okay.
let's try another one here. Let's go log base 2, 9x minus or plus 4 equals let's do 5 here. Let's try that. Okay. So will you well, let's do one more together here. So how are we going to undo the log base 2? That's the key here. How do you undo this logarithm?
I would first like make 2 different logs, like log base 2 of 9x
Nope,
plus
nope,
log 8.
nope.
Okay.
Yeah, we didn't do that at all in the previous problem. Like this is the same problem as what we first did. Like there's no difference in terms of the steps. The numbers are different, but it's the same steps. We didn't break apart the log. You can't do that because it's a summer difference inside here, inside the logarithm up here at the top. What did we do here? Like what was I trying to show over here? Log base 3, you undo it, whatever the log is with the same
Oh,
number.
so it
Yes.
would be a lot like 2 squared, right? Like for when you want to undo the log, it
Yeah.
becomes 2.
So in this case, you're going to put a 2 here and a 2 here.
Okay.
All right.
All right.
So on the left, it undoes the log completely.
Okay. 9.
And then go ahead and solve this the way you did the previous one. You're going to undo the plus 4, and then you're going to do the 9.
Okay. I did not hear what you said because my dad came into my room for some reason. So can you just like
Sure.
say it
Yeah,
one more time?
just asking you to solve this for x. Solve for x. Just like we did in the previous problem, you're going to undo this plus 4 by subtracting both sides, then you're going to divide by.
Okay. Minus. That says 32, right? Or 3 squared because I can't
Yes,
see. Okay.
32. Yeah, 32.
Okay. 9x equals 28. Yeah,
Okay.
divided by 9. So it would be x equals 28 over 9. If it was 27, it would have been really nice.
Yes. Any questions on that? I mean, I'm gonna give you one just like it. You're gonna undo with the 2 or whatever number is here. Maybe it's a 3 or a 4 or a 5, who knows? Then you're gonna solve the equation.
Okay.
All right, here we go. Let's go log base 6, 2x minus 1 equals 1. So give this a try, please.
All right. So I got like the log like removed. I put 6 in front of it and then 6 near 1. Would it be like a now that's where I'm struggling is would it become 61 or just 6?
So in the previous problems, it's 2 to the power of 5. 2 to the power of 5 means 2 times 2 times 2 times 2 times 2, which is 32.
Okay, that gives me more of an idea. Okay, so it just would
And
be
it,
6.
yes, exactly.
Okay, thank you. Now I can continue solving it.
Okay, good.
X equals 7/2.
So 7/2, good. All right, so let me give you one more before we move on to another style of problem. Let's go log base 3, 6x minus 5 equals 2.
Okay. X equals 14/6.
Okay. Does that reduce?
Yes. It can be 7/3.
It is 7/3. Good. All right, well done. Any update here on this? I'm not seeing that the assignment has opened up the review assignment.
I'm refreshing my page. No, it hasn't. I think he always responds late at night. I don't know why. I get he's busy, so that's understandable.
Yeah, well, we're just hoping for the best here.
Yeah.
All right,
If he responds the moment we finish, that's gonna be so upsetting. I'm gonna be so
yeah,
upset.
well, good news is we'll get it done tomorrow and be able to move on to
Mm-hmm.
the new lessons. Okay.
Yeah, you got them positive.
Yeah, so kind of a related type of problem here is, let's say we're asked to solve the natural log of 4x plus 5 equal to 2, equal to 2. Okay. So this is a lot like the problems we were just doing, except instead of log, it's ln. But really natural log of x means log base e of x.
Got it.
So how do you undo log base e? What's the base in this case?
It's E.
E. So on both sides here, you're gonna write an e and e. So on the left, it undoes the ln. It becomes just 4x plus 5. On the right, it's e squared. And it's like, well, what is e squared? Well, e squared is a number. We're going to use the calculator maybe for it. But don't get too discouraged by that.
So like what I write, what is like in the
You just write
calculator,
this, you just write this for now. And we're gonna go to the calculator at some point and do that here, but let me keep going. So next you subtract 5 from both sides. Now you can't really subtract 5 from the e squared. It's just written off to the side there,
okay,
right? It's like a little bit weird. It's like, well, it's odd. We want it to be something, but it's not. It's just e squared minus 5. And then to get rid of the 4 in front of the x, you divide by 4, but you divide everything by 4. So this is considered your exact answer. Now, if we wanted to go to the calculator, and we should do that, we're going to get the approximation. So do you have your Desmos scientific open?
yes, I do.
Okay, so go ahead and enter that in. It is E. It's literally the letter E, which I don't know if that's good or bad. It's kind of a not intuitive, but
That'd be 0.597, but I don't know
yep,
if I should round up or not.
no, that's perfect. Really good. Okay, next problem, very similar. Let's go natural log of just let's go 1/2 x minus 3 equals 1. So just like the previous problem, you undo ln with e.
Okay, so that would be e to the power of 1, right?
Right. So for now, you just write 1/2 x minus 3 equals e to the 1. And then
Okay,
to solve for x, we're going to add 3 to both sides. We're going to undo minus 3 with plus 3.
all right, so
So it's
1/2 x equals e to the first power plus 3.
yes. Now to undo 1/2, you might say, well, hey, I can divide by 1/2, and that's true. That is totally true, but it's awkward. It's weird. It's better to think of multiplying by the reciprocal on both sides, but you're multiplying everything by the reciprocal, so it's good to put that in parentheses. So on the left here, it's e to the first power plus 3 times 2. It's kind of preferred to put the coefficient there in front, the multiplier in front. Could you
Okay,
go to the calculator and give me an answer for this, please?
sure. That would be 11.43.
Okay, very good. All right, so let me so again, let me ask you the question here. How do you undo ln?
How do you undo ln?
Yes. What have we done in 2 straight problems here?
You put e in front of ln, and then you put it where where the number is that isn't in the
Okay.
in the parentheses.
Yes. So here we go. The next thing here is a problem like this. Natural log of 2x minus 1 equals 3. I'd like you to try solving this, please.
Okay. Okay. Wait, where's the, oh, right there. I forgot I have to put e. Oops. I got 10.54.
Say that again.
10.542.
Okay, so it sounds pretty good. E to the power of 3 plus 1 divided by 2. Yes,
I
very
put it
good.
as a fraction instead of using parentheses.
Right. All right, good job. So that kind of takes care of that type of problem that you might see. Probably wouldn't help to take a look. I doubt the teacher has fixed that, but that's okay. Okay, next type of problem is kind of it builds on what we've been doing. We're going to use some of those logarithm laws next. So this is log of x plus log of 8 equals 2. And that means that we have to first combine the logarithms. If you remember that first law, the sum becomes a product.
Okay.
So it becomes log of x times 8 equals 2. And maybe better written this way, 8x equal 2.
Okay.
Now, there's really a base 10 here, which if it's not written, it's 10. So how do you undo the log on the left? What have we been doing for the last few problems? I know we've been using e, but this time it's a base 10. So what's different about this?
Use 10.
Use 10 on both sides. What is 10 to the power of 2?
10 to the power of 2 is 100. No, wait. No, it is 100. Yeah, it's 100. I was thinking of 10 cubed for some reason. I don't know why. By the way,
So divide by 8 on both sides.
that's gonna be like 5/2. I divided
Well,
by 4.
sorry, no. You can divide both by, like, I would start by 2, so it's like 50/4, and then you can try it again. 25/2. So notice that we started out with 2 different ones. Okay. And we combined them, right? Found the product. Then we use that log stuff. All right. So let's try another one here. Log base 3 of x plus log base 3 of 6 equals 2.
Okay.
So just like the previous problem, you combine what's inside the logarithms.
Okay. So there's two logs, so I would only use one of the threes, right?
And it becomes x times 6 or 6x inside there.
Okay.
So we're just adding an extra step to what we've been doing. How do you undo log base 3?
You put 3 in front of the log and then 3 and then 2. It's gonna be
Yes.
like 2 to the power of 3.
3 to the power of 2.
Sorry,
Yeah.
3 to the power of
Got it.
2.
Yeah.
6
All right.
x equals
Why
3
don't
to
you
the
try
power.
solving it? Yeah, why don't you try solving it from here, please?
So I got 9/6, but I can simplify that a little bit, so it would be 3/2.
Very good. Okay, you ready to try one on your own here?
Sure, why not?
All right, let's go log base 4 of 2x. Sorry, let's go x. We'll just keep it the same, x plus log base 4 of 8 equals 2. So go ahead and try working that out. I just want your final answer.
All right. I got x equals 8.
X equals 8. Good. Now it's
All right.
also possible that we can use some other properties like the quotient rule. So like, let's say it's log base 5 of x minus log base 5 of 3 equals 1. Okay. So if you
Okay.
recall, you can if you recall, you can make this a quotient. It becomes log base 5 of the first thing over the second thing. The x is first, so it goes on top. 3 is on the bottom.
Okay.
All right, so now on the right side, it equals 1. How do we undo?
The log. Oh,
Yes.
it would be by putting 5 in
Good.
front of it and just getting the power. So it'd be x/3 equals 5 to the power of 1, which is just 5.
Okay. Now 5 can be written a lot of ways. It can be written as 5/1 if you want. But do you remember how to solve something like this? It's
it would be if it's a fraction, don't you just have to multiply?
So you multiply both sides by 3 by the number on the bottom.
Yeah.
Does that make sense? So
Yeah.
multiply both sides by 3. So you don't have to write it as 5 over 1. So x equals 15.
Yeah. Okay, x over 15. What's next?
I was going to give you one to try here. Let's go log base 2 of x minus log base 2 of 5 equals, let's go 3. So this is
Okay.
just like the last problem. I'm happy to scroll up and show you what we did there, but it's the same exact steps. Meaning you're going to undo, you're going to combine the two logs into a quotient, undo the log, and solve.
Okay. So x equals 13.
Okay, let's take a look here. Log base 2 x over 5 equals 3. And you're going to use 2 on both sides as the base. So on the left, it becomes x over 5 equals 8. Does that look right to you? Similar to
Yeah.
your work?
Yeah,
And
that
then
looks good.
from here, you multiply both sides by 5.
Oops. So instead of it being I added by accident. Okay, so it would be 40.
X equals 40. Good. Okay, let's
Yeah.
try another one. Let's go log base 5 of x minus log base 5 of 4 equals 1. Give this one a try, please.
X equals 20.
Equals 20. Very good. Okay, so we're gonna kind of transition here to solving a new style of problem. Let's say the variable is on the bottom. Okay, so this is related to what we've been doing, but we've got to kind of look at it this way to start here. Do you remember how to get a variable out of the bottom?
Kind of.
There's a couple of options. I'm going to show you cross multiplying. That's the most common one. So you take they call this a butterfly. Some cases 3 you multiply by 4, and then 9 you multiply by x.
Oh yeah, I kind of remember that.
So 12 equals 9x. And then you divide both sides by 9. Okay. So just like in the previous problems, you may have to reduce your fraction. So like, for example, 3 goes into both of them, so you can divide by 3, and it becomes 4/3, like that. But this cross multiplying is key. That's a kind of a key consideration here. The other option here, let me give you another problem. Let's say it's just like 4 over x equals 8, right? So the other option, when you have a variable on the bottom, is to just multiply by the variable.
Okay.
So on the left, they just cancel. You get 4 equals 8x. Okay, but then you have to divide by 8 on both sides. So in this case, x equals 4 over 8, which becomes 1/2. So you kind of have to decide how you want to do it, and both are okay. So let's take a look at a new problem. Let's say it's 2 over x equals 10. If you wanted to cross multiply here, you would have to write this as a fraction over 1. You can always write a number as being over 1. And then you can show the diagonal multiplication. So 2 times 1 or 2 times 1 equals 10 times x. 2 equals 10x. And then what would you do to solve from here?
I would divide by 10.
Divide by 10. You always look at the side with the variable. So x equals 2 divided by 10 or 1/5.
All right.
Okay. I'm okay to stop here. Really hope we can get to that review assignment tomorrow.
Me too, man. I'm crossing my fingers.
To get back on track here, we're going to need to move pretty quickly again. Unfortunately, it seems like this review assignment really taking its time getting started. So